is going to cover strings and printf. So first off is strings. Strings are just another type of variable. They aren't primitive, they're objects, which means they have methods associated with them. And strings are just a collection of characters. And objects will be discussed more in a later tutorial where we will actually start making our own objects. So for declaring, assigning, and updating strings, they're declared and assigned the same way any other variables are, with type, and then name, equals, and then value. So in this case, string s equals example string. And then you update them in the same way you might an integer. You can just add to them here. So s equals s plus after update. So indexes of strings. Indexes are used to keep track of characters in a string. And strings are zero index, which means the first character in a string has an index of 0, the second has an index of 1, and so on. The index of the last character in a string is the length of that string minus 1. So here's an example. The string penguins rock. The first index, the index of p is 0, and the index of k is 12. And everything in between has indexes that go accordingly. So some string methods. There's index of, which will give you the index of the first time a string appears in str appears in the original string s, and it returns a -1 if it's not found. S.length will give you the number of characters in a string. S.replace replaces the occurrences of s1 with the occurrences of s2. S.substring, index 1 to index 2, will give you the characters from index 1 up to, but not including, index 2. And then if you just give it index 1, it'll go from that first index to the end of the string. S.to lowercase will give you a new string with all lowercase letters. S.to uppercase will give you a new string with all uppercase letters. And S.char will give you a char at that given index. And it's important to know that all of these methods return strings except for S.char index, which returns a char. So under the hood, whenever a string method is called on the string, it isn't edited. A completely new string is created and returned. The same happens when a string is added to with a plus, and this is because Java strings are immutable. You can't change them without creating an entirely new one, because every time a string is changed, its length could vary, which means it needs to find a new spot in memory for it to live so it has enough room. So we're going to do some examples of these string methods. So I'm going to go to source and create a new package called strings and printf. And then I'm going to do new Java class string method demo, string methods demo. And then right click twice to get it to go away. So I'm going to do public static void, lowercase s, static void main string args. Okay, so we're first going to use index of, so I need a base string, string s equals hello world. So I'm going to do index of returns an integer. That isn't a string. I should update this note. But so int index of w is equal to s dot index of w. And then I can also do the index of more than one character. So I could do int index of hello equals s dot index of hello. And whenever you query for a string that's longer than one character, the index it returns is the index of the first part of that string. So if I were to print out these indexes, index of W, I'm going to make that lowercase actually because it doesn't have a capital W. Index of LO. Then plus index of W plus index of LO. Then I'm going to do run. And I'm going to pick string methods demo. So I get 6 because it goes 0, 1, 2, 3, 4, 5, 6 to get to W. And then the index of LO is 1 because it starts at index 1. And then there's dot length. Which will give me another number. So it's the number of characters, 12. And then I can do replace. So this is important, the whole part of it building an entirely new string. So if I do s.replace, and then I say every E with capital E, and then I print out after replace S and run. It didn't actually replace the lowercase e with a capital E, and that's because it's not editing this S at all. What I would have to do is say S equals in order to get S to actually update with that replacement. See, now the E is capitalized. Okay, so substring, system.out.println substring demo. So I'm going to do s.substring from 3 to 7. See what that gives us. Oh, I forgot the plus between there. Okay, so it gave me LO space W. So went from 0, 1, 2, 3, 4, 5, 6, and then it didn't include 7. So it stopped right at the W. And then I can do system.out.println substring only begin index plus s.substring 5. So if I press play now, it'll go from 5 forward. So it went from space, which we know is index 5, all the way to the end of the string. And I can show a version of Hello World with everything uppercase. So system.out.println uppercase version of S plus s.to uppercase. And now everything will be uppercased. And lowercase would do the same thing if it had started all uppercase, or if it had any uppercase characters, but in this case, all the characters of Hello World are already lowercase. And then char at index will just give you a character at a particular index. So I can do char at 4 plus s.char at 4. So now that should give me 0, or sorry, not 0, O, which it did, as expected. Now, something kind of weird about this is I know that my string is only 15 long, or sorry, it's only 12 long because that's what length said, which means I can only access up to index 11. But if I put 13 here, there's not a compile error because at compile time, my Java program doesn't know how long my string is. But if I run it, it'll go through all the other print statements just going along, and then I get this exception that tells me it's an out of bounds, which means it tried to access past the end of of my string. So basically it fell off the edge. See, string index out of range 13. And it tells me exactly where it happened, this line 26. So something to watch out for. We're getting to the part of our programs now. Sorry, try 13. We're getting to the part of our programs now where we can start having runtime errors because we're doing more complicated things. So watch out for that. Just because your program compiles doesn't mean that it's necessarily right. So those are the string methods. Okay. We already talked about strings being immutable. There's also test methods for strings. So you can test to see if two strings are equal to each other. You can test to see if they're equal to each other with ignoring the case of the characters. So an all caps hello would be equal to a lowercase hello with this method. You can see if it starts with a string, you can see if it ends with a string, and you can see if it contains a string. And obviously this str would always have to be smaller than this s, or else this would never always return false. So an example of this would be s equals itself. So we could do s dot equals s. And we still have this error that we never caught, so I'm going to comment that out. I'm going to say throws out of bounds error. And rerun this. So now s does equal itself. That's true. And all the other methods would be called in the exact same way. So that's these test methods. And these will come more into play when we get to our conditionals tutorial. So the null keyword. Null is a special value for strings and other objects that means the variable is equal to nothing. And if you try to run a method on a string that's equal to null, you'll get a null pointer exception, a type of runtime error, just like the out of bounds error we saw previously. And we'll talk about how to deal with these and exceptions in a later tutorial. But for now, let me give you an example of a null pointer exception. Let's say string null string equals null. And now if I try to do something like null string dot to uppercase, it compiles fine, right? Because at compile time, the value of string isn't known or evaluated by the compiler. And that's when I get the null pointer exception. It again tells me the line that it happened on. And at that point, the program quits running because it can't go forward. So I'm going to comment this out and say throws a null pointer exception. And that's it. Strings are pretty straightforward. This is a practice problem for later, and it's about name specialization. So for it, you'll create a string variable that holds your first and last name, and then print just your first name, and print just your last name. Print a version of your name with the first name capitalized, a version of your name with the last name capitalized, a version of your name with all the vowels capitalized, and then print the length of your first name, last name, and full name, and then print if your name starts and ends with the same letter. And you can either take that to mean it actually starts and ends with the same letter, or or you can take it to mean your first name and your last name start with the same letter. And the hint here is to use string methods to accomplish all of this. Okay, so printf. The syntax for printf is system.out.printf, a format string, and then parameters. And this parameters can be, so this format string includes the placeholders, width, alignment, and precision information about the string you're about to deal with. And this parameters can be as many parameters as you have included placeholders in your format string. So we'll see examples of this a little later in the tutorial. So a little reminder about escape sequences. \t is a tab character, \n is a new line character, \\/ is just a single backslash character, and you're always required to have 2 backslashes to print a single backslash character. \quotation will give you just a quotation. You need the slash so the program doesn't think you're ending what you're trying to print. So these are the 3 placeholders that we're going to focus on. %d is a placeholder for an integer. %f is a placeholder for a real number or a double or a float. And then %s is the placeholder for a string. There are a couple other placeholders you can use, but for now, these are the ones that we're going to focus on. So this is printf with width and alignment. This w is an integer that tells you how wide to make the portion that you're dealing with, and it's always defaulted to right aligned. If you want it to be left aligned, you use this minus. So I'm going to go ahead and do a demo of that. So I'm going to double click, right click here, new Java class, printf demo, double click to remove the pane, public static void main string args. Okay, so system.out.printf, and then I'm going to do %4d, and then I'm going to put an X just so we can watch the padding, and I'm say 5. I'm going to do the same thing, but with a minus, so we can watch it left aligned versus right aligned. Then I'm going to do run, print demo. And an important thing to note is, like we talked about earlier, printf doesn't include a new line character. So what we want to do is do \n so that our print statements end up on separate lines, which is generally what we want. So if we look here, we said the width was supposed to be 4, so it did this whole thing, including the number that we're printing, is 4 characters wide. And so we got 1, 2, 3, 4, so 3 trailing spaces, and there's also 3 spaces here. And it's right aligned for the default and left aligned when we have this minus here. And there's also double precision. So if we do a period d, is an integer indicating the number of digits to round to. So if I do system.out.printf %.2f, and then I say 5.674379. And then I press run. Forgot a new line character. Rerun it. It only gave me the 2 decimal places. I can also include a width, so I'm going to say 6. Tell it how much padding I want. And if we look at the 6, it includes the decimal point as well as what's after the digit, after the period. So it's 1, 2, 3, 4, 5, 6 wide. So it includes the decimal point as well as the characters after the decimal. And again, like with the integer, I can left align it. And that's it being left aligned. You can also do the alignment and width with strings. So I'm gonna copy this, but instead of 4, I'm gonna make this 20. I'm gonna make this testing, and instead of a D, so we get this, that they don't match, and it's just a warning. And so I probably want to fix that, so I'm going to change this D to an S, and print it. And now, there's testing, right aligned, left aligned, 20 characters long. And that's pretty much all you need to know about printf formatting for now. And the practice for later is to create a formatted receipt. So you're going to edit the receipt program from the types, variables, and expressions tutorial to include the name of the customer on the receipt, and then have the values formatted to 2 places after the decimal for the money amounts on the receipt. And then you're also going to make the alignment look like a normal restaurant receipt with the information on the left and the dollar information with the appropriate currency symbol on the right. And that's it. I hope that was helpful. Strings in printf tend to be pretty straightforward, with printf being a little bit more complicated. But if you remember the 3 different placeholders and in general what the width and decimal is, it tends to work out pretty well.